One of the concepts in Micro 1 that can be tricky to kind of grasp initially is the difference between an output problem and an input problem. How to identify them, and why does it matter? Once identified, what's the difference when calculated comparative advantage and absolute advantage? I'm going to use your assignment 1 example. So this was the alpha beta countries producing apples, oranges, and cars and bikes to demonstrate. So when I say output problem or input problem, what I mean is which variable is being manipulated. For an output problem, it says alpha and beta, how many apples and how many oranges they can produce per acre. So alpha can produce 2 apples per acre and 4 oranges per acre. Beta can do 4 apples per acre or 3 oranges per acre. The input, the land being used here, the acres, is constant. It's not changing. But what is changing, what is being manipulated here is the output, what is being produced. In this case, apples and oranges. So this is going to be our output problem. And let me initially juxtapose that with our input problem, where the difference here is how many people does it take to make a car in alpha and a bike in alpha, a car in beta and a bike in beta. In this case, the car and the bike, what is being produced, this is the output, is constant. It's not changing. What is variable or being manipulated are the inputs, the amount of people it takes to make a car or a bike. That's why this is an input problem. Once you've identified as an output or input, you go about identifying the absolute advantage differently. So for an output problem, we want to know who's best. Who's best at producing apples? The country that can produce 4 apples per acre or 2 apples per acre. 4 is better than 2, so here's my absolute advantage. And in oranges, alpha can do 4 oranges per acre, whereas beta can only do 3. 4 is better than 3. Here's my absolute advantage. When I'm looking at an input problem, it's, again, the idea is the best. So in this case, it takes 4 people to make a car in alpha, or 5 people to make a car in beta. What's better? Well, in this case, to be more productive, you want to use fewer inputs to make the constant output. So 4 is less than 5. Here's my absolute advantage. Beta can make a bike using 1 person. Alpha takes 2. In terms of production, only using 1 input to make a constant output, that's better. Here's my absolute advantage. Now what I want to do is I want to calculate my opportunity cost. So my opportunity cost for apples, my opportunity cost for oranges. If it's an output problem, and remember I stole this from Mr. Clifford, so it's other over. So I'm looking at apples, I'm going to take my other one and put 4 over 2 equals 2 oranges. The other way to think of it, it's a 2-to-1 ratio. 4 to 2 is a 2-to-1 ratio. If I decide to keep an apple, every apple I keep, I'm giving up 2 oranges, if you want to just conceptually think about it in your head. For all opportunity costs, once you calculate one correctly, the reciprocal will be true for the other. So if this is 2 oranges, it's going to be 1/2 apple per orange. And other over will be 2 over 4. Now if I go down to beta, other over, it's 3 over 4 equals, I don't need to simplify it there, 3 over 4 oranges. And this would be 4 over 3, the reciprocal, 1 1/3 apples. When I'm figuring out the comparative advantage, it's whatever the cost is lower, the lower opportunity cost. So if I'm looking at apples, would I rather give up 2 oranges, or would I rather give up 3/4 of an orange? I'd rather give up 3/4 of an orange. Comparative advantage. If beta has the comparative advantage in apples, then alpha must have the comparative advantage in oranges. You cannot have 2 comparative advantages. Now let's look. 1/2 apple is less than 4 over 3 apples, or 1 1/3 apples. So here's my comparative advantage, which means alpha is going to specialize in oranges, and beta in apples. Now let's go down to my input problem here. For an output problem, you go over and input. The two ways, one I like, which I think helps, is input I first. We're in an I first society, so we're talking about cars. Cars goes first, I first, so it's 4 over 2 equals 2 bikes. The other way to think about it, I have 4 people making a car. If I not making a car, those 4 people could be making how many bikes? Since it takes 2 people per bike, those 4 people could make 2 bikes. The reciprocal, 1/2 car. And then I first, 5 over 1 equals 5 bikes. And the reciprocal of that is 1/5 of a car. I'm going to go the opportunity cost of a bike and just conceptually say it out loud. If I have one person making a bike and I decide to have that person make a car instead, how much car could they make? And if it takes 5 people to make a car, that one person can only make 1/5 of a car. So now where's my comparative advantage? If I'm making a car, would I rather give up 2 bikes or 5 bikes? I'd rather give up 2 bikes, comparative advantage here. And I'd rather give up 1/5 of a car per bike than half a car. And so alpha is going to specialize in cars, and beta is going to specialize in bikes.